Hey guys, how are you? Welcome back to the channel. Today is day 31 of Upskilling myself, and it's the first day of a new month. So let's see the DSA problems that I solved. So the first problem is evaluate reverse Polish notation. So it's nothing but postfix. So we have been given an array of strings which is in the form of postfix. Okay, so we have to evaluate it and give the answer as output. Okay, so if you see over here, 2, 1 plus 3 star, what it means is you have to sum these two numbers and then you have to multiply this 3 and the sum of these two numbers. Okay, so you can see over here the equation. So to solve it, you use stacks. So first of all, we create a stack to store the numbers. So initially what we do is we push the first string as a number. So we convert string to integer and then push into the stack for the first element. And then if we find an operator, we assume the second element as the top of the stack and the first element the top of the stack after popping. Okay, so in this case, if you see, if we do 13, 5 and slash, so you know that we have to do 13 by 5, right? When we push into the stack, it will be like 13, 5 and we get slash, it will be 5 divided by 13. So the equation would be wrong, right? So for it, we consider this as the first and this as the second. Okay, so you can see over here. Then we push the result into the stack. Same for the other operators, and then we return the top of the stack, which is the output. The second problem was remove duplicate letters. So we have been given an array and we have to remove the duplicate letters and give the answer into the smallest lexical order. So now if the string is C, B, A, C, D, C, B, C. Okay. Now if you remove the duplicate characters, the string can be anything, like it could be A, B, C, D and A, D, C, B and all that stuff. But we have to give in the smallest lexical order, right? Which means the letter over here should be less than the alphabet over in the second place. If A, C, B, D is not possible, then even A, C, D, B works. Okay, if that's not possible. But if this is possible, then we have to output this. Okay. So to solve it, we create a frequency and a scene array and a stack to do the operation. Then we traverse the array and decrement the frequency. If the character is seen, then we skip the iteration. You can see over here. Then while the stack is not empty and the frequency is greater than 0 and the top is greater than the character, we remove the character from the scene array as well as pop from the stack. Then we push the character in the stack and then we also add it into the scene array. And finally for the output, we convert the stack into a string and then reverse the string. Okay. So we have created the frequency array, the scene array and the stack. Then we put everything into the frequency array. Then we traverse the array. Then we decrement the frequency of the character from the array. If it's already seen, then we continue. Then while the stack is not empty and the character is less than the stack of top and the frequency of the character is greater than 0, then we set the scene as false and then we pop from the stack. Then eventually for every iteration we push in the stack and then we set the scene of the character as 2. Then we convert to string, then we reverse and then we return the answer. The final problem was time needed to buy tickets. So we have been given that n people are standing in a queue and we have to output the time taken for the person at the position k to finish buying. Okay, so in this case k is 2. So if you see 2, 3 and 2, so this is the guy whose time we have to output. Okay, so if you see 2 on the first iteration, the 2 will become 1, 3 will become 2 and 2 will become 1, then it will become 0, it will become 1 and it will become 0. So if you see, when does it become 0? It becomes 0 on the first, second, third, fourth, fifth and the sixth operation. Okay, after the sixth iteration it becomes 0, so you have to output that. So a brute force approach would be just traverse with pointers and you can easily do it, but the time complexity would be very high, right? So what we do is we set time as 0, then we start the traversal. So we should do it in O of n time complexity, which is the most optimal one. Then if I is less than k, which means if 2, 3, 3, 4 and 5, right? So if this is our k and I is less than or equals to k, then we have to add the minimum of the numbers and k into the time, else we have to add the minimum of the tickets of I, which is the numbers, and k minus 1, as k would be completed before this, right? And then we return time. Then for the development part, I did the revision of Linux. I think the revision of Linux would take around 5 to 6 days, like practicing all the commands and stuff. And I did YouTube stuff and I did the revision of all the DSA problems that I solved till now. So thank you guys for watching and see you on day 32.